Okay, next topic we'll be discussing. We have the topic 4 for emission reduction innovations. So we're done with the SOx, NOx, and the particulates matter. So now we will be going to the carbon emission. Okay. So this is the effect of global warming. We're done with the scrubber. Have done with the particulates matter. We have done with the electrostatic precipitator. And now we'll be going to carbon capture storage system. So this is the uh, carbon capture storage system. We have here exhaust gas in, going to a scrubber to clean or to remove the SOx, and then going to a rich solvent, and then the exhaust gas can go out cleaned. Okay, cleaned exhaust gas. And then this rich solvent captures the carbon, put it into this one CO2 stripper, reboil the solvent, remove the CO2, going to a compression to drying and then cooling and then putting it at a CO2 storage. And then the solvent can be used back again to sprayed in here. Okay, so solvent is sprayed and then going down and then reuse, then remove the CO2 and then reuse the solvent. And then this CO2 will be stored to port. Okay, so carbon capture and storage system. CO2 battery. So you can also make a CO2 battery using this empty CO2 battery, full CO2 battery. So it's not really, maybe this is not an electric battery. Okay, so CCS technology allows capture up to 40% of carbon dioxide emissions with the potential of exceeding 90% in the future. So CO2 is captured by a special chemical. Chemical is stored in a tank on board. Chemical is pumped out in port and the CO2 will be released for possible reuse. So this is the control system, control room. Then we have here the scrubber and the CCS. So carbon capture is another technology that can be added to the scrubber platform. Carbon capture removes CO2 and stores it as a liquid until it can be disposed of rather than releasing it into the atmosphere. So land-based carbon capture systems have been used successfully for many years, demonstrating the maturity of the technology. So this technology was already used in the industry for quite some time now, maybe more than 50 years now. An onboard carbon capture system could reduce a vessel's carbon emission by up to 70% depending on the technology used. So how does a carbon capture system work? So a carbon capture system has 5 main stages. We have the preconditioning, the absorption, the desorption or stripping, and the liquefaction and storage. So the first stage is the preconditioning. This is where the exhaust gas is cleaned, cooled down. For high sulfur fuels, it requires a scrubber to remove SOx and then a WESP to remove PM. So you can combine both here. We have here the scrubber and the WESP. Wet electrostatic precipitator. The pre-treated exhaust gas then travels to the bottom of the absorber. Here, another tower. The second stage is the absorber, a liquid amine-based solvent. So, amine yung gamit nila, amine-based solvent enters the top of the absorber here at the top, where the gas and solvent mix. This captures the CO2 in the solvent. The clean exhaust gas exits the system upward, and the CO2 saturated solvent is pumped via a heat exchanger to the stripper. So this one pumped via a heat exchanger to the next stage, which is the stripper. The third stage is the stripper, this one. The solvent is heated, releasing the CO2. So the lean solvent is recirculated to the absorber and reused. So the solvent can be reused back here. Okay, so the CO2 is stripped and going to the fourth stage. The fourth stage is liquefaction. The CO2 is compressed. So meron tayong compressor. We have a compressor here. Dried and cooled down to form liquid form for storage. Then nilalagay sa storage tank. The fifth and final stage is storage. The liquid CO2 is pumped through pipes to onboard tanks where it is stored until it can be offloaded to ports or store facilities, store reception facilities. So how can carbon be captured from exhaust gas? So there are several different ways to capture carbon from exhaust gas. Membrane-based systems have a large footprint and are energy intensive, so they are currently generally better suited to land-based carbon capture. Companies such as Wärtsilä are exploring cryogenic and other novel carbon capture technologies for maritime use. So these technologies have potential in the long term, but are not yet mature enough to be used on board ships. So solvent-based technology is the most mature method for onboard carbon capture. It is based on factors including cost, scalability, ease of operation, maintenance, reliability, and ease of integration. This is how it works. So the amine-based solvent is absorbing the CO2 and then going it here, then heated it up. So the amine is reused. The CO2 will be compressed and put into storage. Okay. So these are just examples. High pressure carbon dioxide, low pressure carbon dioxide. Ooh. This is the solvent we use. Ooh. Okay. So carbon capture can help the maritime industry reduce greenhouse gas emissions. Vessels owners and operators have several options available to reduce emissions, from switching to non-fuel fossil-based or low fossil-based alternative fuels to adding energy-saving technologies to their vessel. An onboard carbon capture system could replace a vessel's CO2 emissions by up to reduced 70% reduction. So IMO's target is for the shipping industry to be carbon neutral by 2050. So this is a very viable choice for the ship. Okay. How can I future-proof a vessel against tightening regulations? You can install a fuel flexible engine and related tank capacity, so you're ready to use an alternative fuel, or you can use this CCS. Okay. Benefits. Could remove an incredible 30 million tons of carbon dioxide from atmosphere every year for Wärtsilä. Challenges and limitations. A wide variety of vessels can be benefit from a system designed for straightforward. There are three main challenges. The first is that carbon capture comes with an energy cost. The second challenge is that the CCS system takes up space. And the third challenge is what to do with the captured carbon. So what do they do? What happened to stored CO2? So what they do is the liquid captured carbon is stored in a tank on board and then offloaded at port reception facilities. Shore-based carbon capture systems such as those used in cement and fertilizer production already transfer their carbon to these ports. With some investment, this infrastructure can be adapted for the maritime industry. So captured CO2 can be permanently stored under the sea in depleted oil wells or saline aquifer. So they put this CO2 at the bottom of the land, or yeah, so this shale sand, carbon dioxide, native groundwater, and carbon bearing minerals. So CO2 dissolving into water, physical container under cap rock, mineral formation reaction, trapping of separated droplets. So CO2, liquid CO2 is put back. So as you can see, fuel is from underground, right? So you get the fuel, and then those spaces in which fuel is empty already, so you can put back the stored CO2 or the liquid CO2 in those spaces. So you're just putting it back to where it came from. Some uses ocean carbon storage, so they put it under the sea, under the ocean. So will the ocean sink for fossil fuels? CO2 change with time. CO2 absorbs the atmosphere. So CO2 plus H2O is equals to carbonic acid, and then combined with hydrogen ion plus H bicarbonate ion, and then CO2 plus water makes bicarbonate. Bicarbonate stored in the ocean interior. So can we use bicarbonate in our Coke? Not. Maybe not. Ocean interior. So we put it under the ocean. The aim for it to be possible to offload CO2 from a ship at the same time as other operations like bunkering, fuel, or loading cargo. So usually they combine. So marami na tayong bunkering, no? Meron tayong fuel bunkering, we have lube oil bunkering, we have diesel bunkering. Ngayon, meron na namang CO2 debunkering. Tawag, ano bang tawag dyan? Okay, so this one, they put it thousands of feet underground beneath the water table. Ooh, so far. This CO2. And then you put the CO2 under here. 50 million metric tons by 2030. So many. 100 million metric tons by 2040. Environmental impacts. If all vessels currently sailing on fossil fuel were to install a CCS system with around 70% capture capacity, emissions could be reduced by up to 700 million tons per year. So put it under the. Ooh. So costing is not our problem, but it will affect also. So they put it here underground. Ooh. Who can use carbon capture? All the ships can do. Basta may pera lang. So this Mitsubishi carbon capture technology. Exhaust gas. One. Onboard capture. So these are tanks for our carbon capture. You put the carbon here. The liquid carbon here. So many tanks. Ooh. Nice. This one. Carbon capture tank. For storage. So this is installed carbon capture. The funnel here. Carbon capture in here. So this is currently on field 3. So this is used nowadays. So this is another one, cryogenic technology for storage at sea. Carbon capture. Also, we have carbon capture in here on this ship, Nordica. Ooh. That's it. That's it for. But we have another topic, the decarbonization. What's that? The last topic. I'll check what topic is that. We have the just transition decarbonization by 2050, which is the last topic for this LO. Okay, so I hope you learned something today. See you on our part 5, the last topic for this LO, which is the just transition decarbonization 2050. Thank you very much for watching, and please do like and subscribe and share our video to your friends. Goodbye.